Hello, in this video I am going to explain and demonstrate experiment number 3 of embedded controller lab, stepper motor interface and rotate clockwise and anti-clockwise. So as we all know, we use the pin number 15, 16, 17, 18 and 19, these 4 pins for this purpose, and we set all these 4 pins. You can see I am pointing on the screen. So these 4 lines will carry the bit stream what is required to rotate the stepper motor. So we drive the stepper motor in a full wave drive or a half wave drive. Here I am using a half wave drive. Only one coil is made on at a time, and this is these 4 pins where I am pointing. These 4 pins are used for this purpose, and these are configured for general purpose input output. To configure the register as a direction, as you know, we have to generate the microcontroller has to generate the signal to the stepper motor. These pins has to be set as an output ports. By default all ports are input ports. We have to set it as an output port. For more details about all the registers and register settings, please watch my introductory video for this lab. So in FI, for this experiment, to rotate the stepper motor clockwise and anti-clockwise, we have to set these 4 bits: P0.15, P0.16, P0.17 and P0.18 as an output pins. And then for that we have to configure this register FIO direction register, LPC underscore FIO direction. So GPIO, general purpose input output. So we odd with this value. So this is the value what is shown in this register format. You can see here. Then this is configured as an output port. So in this program I am going to explain the program of stepper motor. So we have to include the LPC1768.h, and the delay is required in between the 2 step values. That 2 step values delay is written as a delay function is written, and it is made use. So look at here. In the main function I am using a rotate character. I am declare a variable, and every time I am changing the value of this value is set to 1 to rotate clockwise, and then I will set it to 0. I will change it to 0. Then I will check that in if for anti-clockwise. So and then I am setting the F direction, fast input output direction register I am using to set the pins 15, 16, 17 and 18 of port not as an output port. So in a super loop, while one loop, this unconditional loop execution, infinite loop execution. So this if it first check for rotate is whether it is a 0 or 1. If it is a 1, it executes this. Then it will rotate clockwise. So every time I am using the FIO pin register to set the values, send the values to the output pins, that is 15, 16, 17 and 18 pin of the port not. Note that speciality of this is explained even in introductory video for this lab, where I am explained the difference between using FIO pin and FIO set. If you use that particular pin only set to 1, and rest all the pins the previous value whatever it's there in those bits, that is taken as it is, sent as it is. So that is not required in this that experiment. So what we have to do is we have to use FIO pin register to set the output, send the output, or set the output required pin, that is 15, 16, 17, 18 pin to different values, and rest all I want at that same time as a 0 we have to set. For that we are using this pin register to set the output value. So how to set it? So this is the command I have to write, or what you call the instruction I have to write: LPC underscore GPIO arrow mark FIO pin. I have to send this value to that, and I have to call the delay between the two steps, and next value I have to set 8, 4, 2 and 1. So in this order we have to send the values. In a reverse order if we send, it will rotate in the anti-clockwise. And time to time, based on the switch, we are using the two switches, switch, then that switch to I'm using of the port to 2.11 pin, pin I'm using the switch which is connected to that I'm using. I have configured that for changing the rotate variable value. If that switch is on, and when I press that switch, it will change the value of this rotate from either 0 to 1 or 1 to 0. Because of this, the stepper motor will rotate in clockwise and both anti-clockwise. Let's see the demonstration of this in a lab. The next slide.
Hello. In this video, I am going to explain and demonstrate the experiment number 3, interface a stepper motor and rotate it in clockwise and anti-clockwise direction. So for that, to create a code to rotate, we have created one folder on desktop, and in that we have created one more folder called as step to store the projects and related files. Then we create a new project. So new project we create in the folder which is created as a step. And then we select the target. The target is NXP LPC1768. Once we select the target, then we have to create a C code, and this is the C code what is written to rotate stepper motor in clockwise and anti-clockwise direction. Then we save this C code as a step.c. Once you save, we have to add it to the target source group, target board. Then we select that. At the same time, we select the system file too. You can see here step C, the file which is created by us by writing the C code, and system.c which helps with support file. Then we have to save and we have to build. Once you build, you can see here it will display syntax or syntax errors. So there is no error, there are 0. So now what next we have to do is we have to create a hex file to dump to the target board. So that's why we have to select right clicking on the target, the options for target. The options for target, when you click, we get this window will get open, and in that we have to select output and we have to check mark the create hex file. And then the hex file is get created by the name step, the C file what is created. Then again, once again we have to, after selecting that options, we have to build. When you build it, the hex file is get created. Once the hex file is get created, so the next step is we have to open the Flash Magic that the driver software which help to dump the code from the PC where we have created the file, build the file, and the hex file is get created to the target board. Then we have to select a particular hex file. Look at here, it is downloaded to target. So before downloading to the target, we have to set the settings which are displayed on the screen, and then we have to choose the option present on the board. So there is two modes are there, program mode and execution mode. We have to keep the board in program mode while dumping the code, and we have to reset. After resetting, we have to select the option start in flash magic driver. Now the program is get dumped from host PC through USB to the target board. In the target board, once the program has dumped finished, then we have to select the option execution mode, then we have to press reset. Look at here, the stepper motor started rotating. So to change the direction, they have provided the two switches are programmed for selecting the direction. Now it is rotating in anti-clockwise direction. To rotate in clockwise direction, I have pressed this button. Then once, suppose you want to change again to clockwise anti-clockwise, you have to press another button to rotate it. And the stepper motor is connected to the interface card which is on the evaluation board. Thank you.
Thank you for watching the video. If you like, press the like button and subscribe. Thank you.